Welcome. Thank you for joining our Laboratory Practice Best Practice Series webinar. I'm Becky Melody, your hostess for today's presentation. The discussion today will cover introductions, webinar logistics, direction for post-webinar collaboration, and our discussion topic, Lean Labs, creating efficiencies in laboratories for the life sciences. We're pleased to have Diane Gleinzer presenting today. She's been the Vice President of Operations for U.S. Data Management since 2002. She has over 22 years of experience in life science-based industries, encompassing quality assurance, quality control, validation, and regulatory compliance for research and development, clinical affairs, manufacturing and packaging, laboratory analysis, and auditing under GXP regulations. As a member of the senior management team at USDM, Diane leads a highly skilled team of implementation and compliance engineers, and she's been instrumental in establishing USDM's practice groups. USDM is focused exclusively on the life science domain. We're the market leader in providing IT, quality, and regulatory compliance professional service solutions. We're headquartered in Ventura, California, and we're a compliance partner for many of the best-of-breed vendors, including Oracle and SAP. We've delivered more than 1,000 successful projects with over 200 life science clients, and we're the preferred partner for small, mid-tier, and large life science companies. Our various dedicated practices include IT and virtualization, quality and auditing, ECM, ERP, PLM, enterprise quality management, manufacturing automation and equipment, clinical and drug safety, business intelligence, project management, GRC, and of course, our laboratory practice, which includes both systems and equipment. The content of today's presentation will be covered in approximately 30 minutes, and then we'll invite you to post questions for our team via the iLink message board, which you'll find in the lower left of your screen. Or you can join the discussion following today's presentation on LinkedIn and post any questions or comments there. Please know that the overall goal of today's webinar is to facilitate discussion, share ideas, explore solutions together. We do appreciate you taking your time to join us, and now I'll turn the presentation over to Diane.
Hello, everybody, and thank you once again for attending. In today's presentation, we'll be discussing the concept of a lean lab, how it started and what it is. We'll be talking about value stream mapping to help identify the inefficiencies in your processes, how to increase efficiencies in the laboratory while eliminating waste, and managing the performance once you create a leaner lab environment, managing the performance and developing key performance indicators for measuring that performance moving forward. Laboratories in life sciences today are faced with a lot of volatility and variation, both in the types of assays they perform, as well as the volume of samples that have to be analyzed. Adding to that, you have the increasing complexity of regulations, not just from within the United States, but from Europe and Asia also. Lab work itself requires a great deal of attention to detail. But at the same time, you have to be efficient and effective and be able to achieve high degrees of productivity. An implementation of lean practices in a laboratory can help to achieve the regulatory compliance you need in an efficient and highly productive manner. Performance in laboratories can be negatively affected by a myriad of issues. The amount of workload, the volatile workload in the laboratory with significant peaks and troughs. Often you have days where you get incredible numbers of samples that need to be analyzed in a reasonable period of time, and other times no samples are received at all. This volatility can lead to long lead times and long turnaround times for sample analysis results. With a high volume of in-process work, you can expend significant effort trying to control and track and prioritize the samples themselves, as well as schedule the samples. You have people in laboratories have historically made significant investments in software such as LIMS systems, execution systems, hoping that it's going to make their life easier. But that software itself involves a great deal of learning and a great deal of knowledge about your business processes. The software itself will not improve your business processes. You need to have the processes in place first before the software can actually help you. There's a significant amount of non-value added activities in the laboratory, such as unnecessary testing, doing for information-only tests, the amount of documentation that has to be created, and the review and approval of documentation creates a huge burden on a lab workload. And poor documentation practices by lab analysts leading to rework, having to reanalyze samples, loss of data for samples, and having to redo documentation. Another huge source of waste in a laboratory is poor workflow. The lab is not set up to enhance the actual day-to-day activities of the analysts, so they end up walking back and forth or batching sample groups together and staying in one spot, then moving to another spot in the lab. All of that can lead to inefficiencies in a lab environment. In the 1980s, the lean concept began in the Japanese motor industry, and that concept spread across multiple industries, and including coming into the life sciences industry very recently. Labs across the United States are discovering the benefits of becoming more efficient in sample testing, reducing their costs and increasing their turnaround time, getting the results out in a much more effective time frame. Because of the complexity we see in laboratories, because of the workload, some of the other things that we've talked about, the actual tools that are used to increase or promote the lean concept need a pretty good amount of adaptation in order to meet today's laboratory needs. We're going to talk about some of the tools today that are going to help you improve performance and reduce costs in the lab, and that is the overall goal of the lean concept in a lab. As we talk, you'll notice that Six Sigma policies and processes come into play here. Lean and Six Sigma can be used hand in hand, and many of the tools that we use in developing a lean laboratory were developed through Six Sigma philosophies. What we want to avoid here is a one-size-fits-all approach. Laboratories can be significantly different from each other and can actually have extremes at one side of a laboratory with a huge amount of automation, multiple enterprise systems, a large network, everything is all hooked together, works in unison, down to those labs that have just multiple pieces of benchtop equipment with single workstations hooked up to them. So we've got to be able to scale the approaches that we use in a lean lab to ensure that we're not just focused towards the large automation nor the smaller labs. What we do has to be scalable across the board. And understanding the processes that each lab uses and has built over time is crucial to implementing process improvements. Six Sigma structured problem solving, also known as DMAIC, is something that we want to apply when we're looking at trying to implement the lean concept in a laboratory situation. We need to be able to define the problem to start with. What is it that we're trying to solve? What is the issue that's causing inefficiencies in the lab? We have to be able to measure the results of that problem or the issues with that problem. We've got to make sure we have sufficient data available so that we can understand what the problem is and now look for potential solutions. We've got to analyze the situation once we find it and identify it. We need to get down to the root cause of the problem that's causing inefficiencies. Once we have the root cause identified, we can then begin the process of identifying ways to solve that problem. And once we've determined a solution and we've implemented that solution, We need to control. We need to review and reanalyze and ensure that we actually, first of all, have a solution to the problem, but also that we are continuing to see improvement over time where there are other root causes that we didn't expect. In order to implement a lean concept in the lab or implement a lean laboratory, you need to understand your business processes. You need to understand what those processes are made up of. So one of the things that we always want to do is to identify the process and map it out, each step of that process. In that process, you're going to find that there are many value-added activities. And a value-added activity is something that has value to your customer, whoever that customer is. Whether you're a quality control lab analyzing in-process and final samples for a manufacturing lab, or you're a medical lab analyzing samples for a patient. Those things that the patient or the manufacturing area need the most, the results, that is a value-added activity. A non-value-added activity is something that you do in the lab that has absolutely no value to your customer. And there are those incidental activities also that you have to have in place in order that the value-added activities can be carried out. For every business process identified, you want to map that process out and you want to look for potential sources of waste or inefficiency. And the places that you want to look, or some of the places that you want to look for this inefficiency, are in movement of material. Getting material, where is it initially stored and how does it get into the lab? How does it get back to the place it needs to be stored? How about movement of samples from the freezer to the bench? Look in the transportation of material. Look at your inventory, the spaces and the funds that are used to store your inventory. Do you have a lot of excess inventory on hand, or are you always running out and having to reorder and you can't analyze samples until you get the new supply? Movement of people through the lab. Does the work flow in order of the steps that you have to perform? So do you have to walk back and forth continually in order to perform the analysis? Waiting, delays in analyzing samples for any reason, or long lists of samples waiting to be analyzed. Do you have just a few samples and you wait for a number of samples to come into your lab? Or do you have long lists of samples and very few people who can analyze those samples? Overproduction is another area that you want to look for risk. Are you doing more than your client is asking you to do? Are you doing a lot of informational testing, other things that are not value-added activities? Overprocessing. This is a huge issue in most labs. The amount of paperwork, bureaucracy, and in-process checks can be overwhelming. And you want to look at the process. Is there a way to simplify those processes? And how about defects? Rework due to errors, due to documentation problems, loss of samples, mistakes. Is there anything in there where we can reduce waste and possibly identify some inefficiencies? Once you map the current process, draw it out, and highlight those areas where waste can be found, you want to then think about how do we make this process better? We've got these inefficiencies, we've got this waste. What can we do now to make this process a much more efficient, effective process? And create a future map or a future state map of what that ideal process might look like. Note the differences. Many times what you'll see is there's not one major difference. There's not one huge area in which you're going to find waste or inefficiency, but you're going to find many, many small areas that over time will add up to a lot of inefficiency in a process. Once you've identified the inefficiencies, you have a pretty good idea of what you can do to make a better process. Take a look at the people in your lab. Identify the key resources required for a business process and define roles and document those roles to make sure that we're making efficient, effective use of an analyst's time. Once you've identified those roles, put the process together with those roles and simulate what you think. Now it's time to ask what if. As you walk through a simulation of the to-be process, ask, what if we added additional equipment at this place? If we can put additional equipment here, will that simplify this process? What if we add another shift or extend the workday by a couple of hours? How does that affect this process? What happens if we can eliminate some of the steps identified as non-value added? We may not be able to eliminate them all. Non-value added steps are there, may be there for a reason. We have to look to see if it's possible to eliminate them. But what happens if we can do that? Take a look at your lab layout overall, the floor plan, and the workflow. The goal is to ensure that the work can flow through value-added steps with little or no delay. We don't need analysts walking into each other. We don't need analysts standing in line to use one or two pieces of equipment. Analysts will tend to perform work in batches in one area if they have to move between different labs or different areas within a lab. And that may increase the time to analyze samples because you're waiting for an entire sample batch to finish this one step before you move all the samples on to the next step. So now all of the samples are dependent on the last of the sample batch. Reducing that batch size may increase your sample turnaround time and increase efficiency because it will be processed more quickly. We're no longer waiting on those last samples of the batch to be analyzed. Ensure as many process steps as possible can be performed in a close proximity. And in order to do that, you may need multiple smaller pieces of equipment rather than one large piece of automation. So that's some place to look for added efficiency. Even though you're using more equipment, at the end of the day, you're getting faster turnaround. So on the left, you'll see there's a picture of kind of a spaghetti chart of a poorly organized workspace where people are having to move back and forth continually. On the right, this is a far more efficient workspace. One of the other things that you want to look at for increasing efficiencies is leveling the overall workload and sample mix so that you have a balanced amount of work in the lab every day. It's just useless to have your analysts sitting around with nothing to do 2 days a week and they're overwhelmed 3 days a week. It's better to analyze smaller batches or do whatever you need to keep them busier on a consistent basis rather than overwhelmed some days and bored the others. Samples won't flow through a laboratory unless you ensure that the workload is level. And on the other hand, you can't level the workload unless you can allow samples to flow through your lab. You really want to establish a situation where once that sample starts an analysis process, it moves through from beginning to end, and it never stops the processing once you begin it. This will help decrease your throughput time as well as reduce your lead time. You always want to use customer demand as a key priority when you're looking at scheduling samples and starting the analysis of samples. But other than customer demand, samples should always move in a first in, first out flow. In many labs, you need to level the whole mix of sample types as well as the overall workload in order to make sure that you're effective. There's a few ways of leveling strategies that are out there. We're not going to go into a lot of detail on those today, but I would be happy to talk to you about them separately if you'd like to try to use these. There are such things as rhythm wheels. There are trains. All of these are scheduling tools where you actually have a fixed repeating sequence of tests that are designed to meet the level demand and make sure that your sample turnaround time is consistent and that your daily workload is more balanced. These tools will allow the design of well-balanced productive roles within the lab, and that will make much more efficient use of your analyst time. What you want to do is stress longer-term planning rather than day-to-day planning. These tools will help you do that. And what you're going to gain from this is these tools will help you to facilitate economies of repetition. Once you can repeat a process, once you have a process in place that can be repeated consistently with consistent results that you can document, you're going to see the efficiency within your lab grow dramatically. And once you've got those repeatable processes, now you can develop standard work. Some people in your lab, just as in any business, manage their time and tasks very well, and others need some assistance managing time and tasks. They're not quite as organized as the other people. Using a standard work approach ensures that once you develop a repeatable role, a repeatable set of steps, and you document that now your analyst is trained on that, you can develop a scorecard, which I'll show you in a minute, that will help to improve the operation of this rhythm wheeler train. And by doing this, by having a repeatable set of steps that people can follow every single time they do this process, you're going to start to reduce errors and failures in the lab. That alone is going to increase your lab productivity. Make sure that you document the role in the process to be followed. This is an example of a scorecard for environmental sampling. So you see that there's a series of steps. In the morning when you come in, you get your lab coat on. You do this process. Then you take a break. When you come back, you start this next process. In the afternoon, after lunch, here's the process you follow. Not every process is going to be able to be controlled in this manner, but the more processes that you have that can be controlled in this manner, the higher the efficiency that you're going to get. You really need to work to eliminate waste in your lab, and waste is non-value activities. We talked about identification of non-value added activities before. Once you've identified those activities, we need to see how we can get rid of them. We want to eliminate any unnecessary steps within a process. Much waste in a laboratory is centered around documentation. You think about re-engineering your test records. Just because you've always done or written a test record in a certain way doesn't mean you can't make it itself more efficient and effective. Think about automating the documentation, the review process itself. But be aware, as you're thinking about that if you don't have your processes properly defined and you don't know what those business processes are, all the automation in the world is not going to help you. So before you invest in expensive software and the time and effort it takes to implement that software, do the value-added mapping, do the business process mapping up front. Once you've eliminated the waste, you've increased efficiencies, you've begun the process improvement cycle, now you need to manage this. So you've got your reduced complexity, non-value-added activities are being controlled some more, the workflow is increasing, you got some improved turnaround speed. How are we going to maintain this and make sure that we've got, first of all, the right solutions, which we can probably tell by gut feel, but how are we going to show management? And how are we going to maintain this process moving forward? One really good way is to create key performance indicators for the lab that you can measure, something that is measurable on either a daily, weekly, or a monthly period. By measuring it and charting it and using a dashboard or just a simple graphics tool, you can enforce the efficiencies. People can see in a picture how much better things are now than they were a month ago, and they can see the continuous improvement, as well as management can see your continuous improvement. Once you develop the right measurements and the right things to measure, you're going to be able to tell at a glance which of your process improvements are working and which don't. And if something's not working, there's another opportunity for continuous improvement there. Maybe we didn't get to the root cause of a problem, or maybe we just identified something that's still a problem and we haven't quite got the right solution. You also want to monitor your processes very closely so that you can ensure when a process begins to go out of control, you can take a very early step, a step very early on to bring it back into control without allowing it to spin for a while before it can be seen. That's going to be very important. You really want to look at some statistical process analysis on your KPIs so that you can monitor these processes and implement effective early change. As you continue through the process improvements, as we all know, are not just a one-time deal. They're continuous. So as you continue to get new processes in, continue to review your old processes, look and see where else change can be effective. Look at your process maps periodically. Business processes change. These process maps are fabulous tools to use as training and also to use for information for the analysts in the lab. So look at them and make sure that they're updated. One other thing that you can do is what we call 5S in a lab. And 5S is standardize, sort, set things in order, shine, and sustain. You want to go through your lab and sort out the information. Look at the instruments. Keep only those things that you use. What about documentation? Sure, most of you have a really good filing system in your lab, but a lot of labs I've been in, there's documentation in every drawer. Nobody can find it when they need it. Go through and make it an orderly lab. Put your documentation in one location. If you don't need that documentation, throw it away. Put it someplace else. File it. Do something with it so it's not in the way. Set your lab in order. Make sure everything in the lab has a place, and make sure it gets put back in that place when you're done using it. Make sure you have the best location for those things that you use regularly. Look at your inventory. How much inventory do you keep? What are the triggers for getting new inventory? How much inventory do you have that's old and never been used? Do you really need it? Can you just get rid of it? Clean everything. Get all the surfaces sparkling. Get rid of any sources of potential complication. Contamination. If you have contamination problems in your lab, that's going to reduce turnaround time and involve a lot of rework. So clean it. As you're doing this cleaning, make sure you look at your instrumentation. Is there a light bulb about to burn out? Is there maintenance due on something in a week that we can do today? And make sure that things are going to be working properly for the next batch of samples. Go through, make sure that you can identify any abnormalities or problems and maybe halt a failure before it occurs. Standardize. Make sure that you have processes and procedures for all of these things, for sorting, for order, for cleaning. How do you do that? Create check sheets and schedules as you need to maintain order in your lab. Once you have an orderly lab, things move more quickly through it. And make sure that you're documenting all the processes and procedures. Make sure that the people are trained on those processes and procedures. And make sure you're communicating your standards to your analysts and to your workers. If we do all of those things, I think that over time and fairly quickly in some labs, you're going to see a great deal of improvement. And certainly over a period of time, even if your lab is reasonably organized now, implementing some of these steps will ensure continuous improvement and continued efficiencies in your lab. Becky, I'll turn it back over to you for any questions.
Thank you, Diane. We sure appreciate you sharing that solid information. We will now open the floor to questions, and while you're typing them in, I'd like to share that the session has been recorded and will be posted to our website, which is usdatamanagement.com, of course. It'll be there later this afternoon, and we'd welcome you and your team members to log in and review today's presentation at your leisure. You just click in there, and it will be the audio as well as the slides that you can view and maybe share the information with teammates. You can also see additional webinar presentations. If you click the webinar tab on our site, then you can see the many previously recorded presentations across our various practice areas along the far right column of the web page there. We would also invite you to join our discussion forum on LinkedIn. We appreciate your insight and any feedback that you care to share to us as we work towards continual improvement. And of course, we'd like to hear your suggestions for future topics. Thanks to those of you posting compliments here in the chat room. And we'd like to ask, if you did enjoy today's webinar, please show us by clicking the like button on the USDM LinkedIn group page, or even better, post a comment there. We'll take you just a moment, but it would mean so much to us, as in 2012, this is going to be an important indicator that our management team is looking at and using as a basis to continue to fund this complimentary webinar series. Looks like we'll wrap up now. Diane, thank you again for presenting, and thank you all for taking the time to join us. We appreciate the opportunity to team with you in working towards excellence in compliance. Thanks again and have a great day.